Now we're going to look at representations of a line. So in example 1, we're going to look at rate of change and initial value given in the context of a problem. So still reiterating a lot of the same things we've been talking about: slope, y-intercept, which is the same as rate of change and initial value, and what it means in terms of the situation, not just in general. So a truck rental company charges a $150 rental fee. So there's something important there we need, in addition to a charge of 50 cents per mile driven. In this problem, you will graph the linear function relating the total cost of the rental in dollars C to the number of miles driven M on the axis below. So first, we're going to start out with question 1, or A, I should say. If the truck is driven 0 miles, what will be the cost to the customer? How will this be shown on the graph? Okay, so if we're talking about 0 miles, that means we want to know what's across from 0, or what my flat fee or initial value should be, which is coming up here. Okay, at $150. Not 1.50, just 150. Okay, so how will it be shown on the graph? If it's the initial value or fee, it's going to be shown as 0, 150 on the graph, which means it is our initial value. So we're going to go plot 0, 150. Okay, and then it says, what is the rate of change that relates the cost to the miles driven? So if we go back up and look, our rate was 50 cents per mile. So 0.50. Explain what it means within the context of the situation. So that was supposed to be a 50-cent charge per mile driven. And it's an increase because it's positive. So we're going to say the cost will increase $0.50 for every mile driven. So on the axis, it wants us to graph the line that relates C to M. So we definitely want to use our slope to do that. Our slope is 0.50 over 1. Now, if you go look at that, is it going to be easy to go up 0.5 to the right 1 when every little block is worth 50? Oh, absolutely not. So we want to manipulate this slope a little bit so that we have numbers that work well. So if I were to multiply it by 100, let's say, because that's easy to do. If I multiplied this by 100, I'd just be moving the decimal point over twice. So that'd be 50. And then if I multiply this by 100, it'd be 100. So if I do that, now I have numbers that are easy to work with. And I know that this is going to be up and to the right because slope is rise over run. So now I can go up 50 to the right 100, up 50 to the right 100, and so on to get my graph. And then I'll take my ruler and connect them. Now it's real world situations we got to consider. I'm not going to put arrows here because I'm not going to go backwards in my mileage or into negatives in my mileage. But here I could continue to drive. So I'm going to put an arrow there. And then you guys know to complete the graph, I'm going to put my equation, which first let's write in part D, and then we'll add it. So write the linear function that models this relationship. So remember, you are using your model of y equals mx plus b. Okay, but you need to use the variables given. So in Y spot, they have the letter C because it's meaning cost. So we're going to put C equals, then the slope we know is 50 cents per X mile, but in our case, they used M for miles. So I'm going to put M, and then my Y-intercept was 150. So that is the equation that models our situation, or the linear function that models it. So now I can go back up here and put C equals 0.50 M plus 150. Okay, so now that you've had that example, you're going to do some practice. Okay, so there's 2 practice questions. I want you to pause the video right now, try practice 1, then resume the video to watch the explanation of the answer. Okay, in the first practice question, Jenna bought a used car for $18,000. She has been told that the value of the car is likely to decrease by $2,500 for each year that she owns the car. Let the value of the car in dollars be V, and the number of years Jenna has owned the car be T. So first it says, what is the value of the car when T equals 0? So that means I'm looking for the initial value, which is the $18,000 that it was worth at the beginning. Then in B, it says, what is the rate of change that relates V to T? Hint, is it positive or negative, and how can you tell? So it is going to be negative 2,500. And that's because this is the rate of change. And it's negative because if you go back up and look, it said it was decreasing by $2,500 each year. So negative means negative is decreasing. Okay, then in part C, it says find the value of the car when. So we might want to actually go down and think about how to write the equation first, or probably what a lot of you do is you wrote the equation earlier than necessarily needed. So if you want to, I'm going to go write it down in part D. It says write the linear function that models this. We would use y equals mx plus b form. But in our problem, the y-axis is a v and the x-axis is a t. So this is going to be v equals, my slope we know is negative 2,500. That goes in front of a t. And then my y-intercept is this 18,000 number. So plus 18,000. Okay? Or some people might choose, because the slope is negative like that, to do v equals 18,000, and then you're subtracting 2,500 times t. Okay, it doesn't really matter. I think I'm going to use the second form just to show you something a little different. So we have 18,000, and we're going to subtract 2,500 times t, which is 1. So if you do that, you get 15,500. For t equals 2, you're starting at 18,000, subtracting 2,500, but this time t is 2. You do that on your calculator, you're going to get 13,000. And then if we do 7, I'm going to replace t with a 7, and you get 500. So now it wants us to plot the points for the values we found in exercise 3 and draw the line. We're going to make sure we use a straight edge that has those points. So we've got coordinates here. What we've got is 1, 15,500. Then we've got 2, 13,000. And then we've got 7, 500. So we're going to go plot those. So we've got 1 and 15,000. Now let's take a look at how much these things are worth. Okay. You've got an initial value, first of all, of 18,000. And there's 5 of these in between. So each one is worth 1,000. So then I'm going to plot 1, 15,500. So here's 15,500 is only going to be halfway to the next block. Then I've got 2 and 13,000. So there's 10,000, 11, 12, 13. And then I've got 7 and 500. So that's only halfway up to the first block. And then when we go to connect them, we need to talk about what to do here. Because if you notice, I'm going to get to a point where it runs into the other axis. So this should have no arrows either way. I'm not going to go backwards into number of years, and I'm not going to go down into negative value of dollars. Okay, so we want to make sure we do not put any arrows on that to show that we shouldn't be going on in either direction. And then since we have the equation of the line, which we already did in part E, we're going to put that equation right on the line. So we've got V equals 18,000 minus 2,500T. Okay, and that completes practice 1 question. So at this point, please pause the video and try practice 2. Resume the video when you're ready to check your answer. Okay, so we've got question number 2 for practice. It says an online bookseller has a new book in print. The company estimates that if the book is priced at $15, then 800 copies of the book will be sold per day. And if the book is priced at $20, then 550 copies of the book will be sold per day. So first, in part A, they want us to identify the ordered pairs that were given in the actual problem. So if I go back up, I see $15 for 800 copies. So that's 15, 800. Okay. And then I see $20 for 550 copies. So that's 20 and 550. So then they want me to plot them on the graph. So we're going to go up here and take a look. First, I want to talk to you about this little marking. This is what we call a break in the graph. So when you create a graph, you're supposed to make sure that your scale is consistent. My y-axis scale is fine. It looks like every 2 blocks is 100, so that means every block is 50. But here you're going to notice we went from 0 all the way up to 15 very quickly. And then we went by ones, meaning every 2 blocks is 1. So this mark here is like 17 and a half. So because we don't have any values until 15, they're getting rid of the earlier part of the graph by doing what's called a break, and that shows that. So we're going to plot them both, 15, 800, and then 20, 550. So we got to do 20, we got to find 500, and 50 would be this line. So we're right there. Okay. So B says, assume the relationship between the number of books sold and the price is linear. So when I see that it's linear, that means we know we have a constant rate of change, which in turn means we have a slope. Okay, so in other words, the graph is a straight line. So we're going to use a straight edge to draw the line between those 2 points. So I'm going to take and connect those 2 points. Okay, just those 2 points. I'm not going to extend it any further because those are the only 2 points right now that we have. Okay, so we're just going to do that. So it says, what is the rate of change relating the number of copies sold to the price? Now you technically have 2 options here. You have the 2 coordinates. So you could use the formula, which remember is m equals y2 minus y1 over x2 minus x1. But you also have the graph. You graphed this. So you could use the graph and then you would be using rise over run. So it's your preference. Since we have the graph, why not use the graph? So I'm going to use rise over run. And I'm going to go up here and look between my 2 points. So reading from left to right, I have to go down. And I'm going down to this line. Oh, no. Going down to this line. So that means I'm going down 50, 100, 150, 200, 250. So that's down to 50. And then I'd have to go over here to the right. From 15 up to 20, I'm going to the right 5. So I'd be going down 250, which is a negative 250, and to the right 5, which is a positive 5. So this ends up being negative 50 or negative 50 over 1. So what is the rate of change of number of copies sold to price? It's negative 50. Okay. So based on the graph, if the company prices the book at $18, about how many copies of the book can be expected to sell per day? So I'm going to find $18, prices on the x-axis. I'm going to find 18, and I'm going to follow it up until I hit the line. It's right here. So if I follow that now this way, I see that it's right here, halfway between 600 and 700, which would be 650. So based on this, how many copies would we sell? We would sell 650 books. Okay. Then it says, based on the graph in part E, approximately what price should the company charge in order to sell 700 copies of the book per day? So this time we're looking up 700 copies, which is a Y value. So here's 700. I'm going to follow that over until it hits the line, which is right there. So I'm going to follow that down and see that it happens at 17. $17 would be how much I would need to charge. And that completes your lesson on representations of a line.